好咁我喺 Google Meet 嗰度貼條 link 俾大家㗎啦。好 hello John, hello. And so you can click on the link and reach to the YouTube Live lesson. Okay, hello everyone, hello. Today we have got quite many things to talk about as an introduction. And it is also an introduction to the whole M2 syllabus. And we will not quite use the textbook today probably, but instead it will be something more as extra, okay. However, they are useful. They are important for us. By the way, is my voice clear enough? Could you all hear me? So please, if you can hear me, say yes or one or whatever. Type something. Is my voice clear? So maybe I need a little time to handle some. One of you has difficulty entering the Google Meet. Okay, clear. Thank you very much. Thank you. Okay, so I first changed the screen to my iPad, and so I can do some more demonstration. So okay, but Brian has switched the Google Meet as well. Also, the YouTube Live link is here. The YouTube Live link is in the chat room. 4026. Okay, I also put the roll call first. So please wait for a moment. Okay. Maybe I reply to some chat room questions here first. No need PYC, I can't hear, right? Yes. So you can use your own, or if it is more convenient to use the Google account, both are okay. So I don't mind. Also, okay, hello. Okay, so I think we are all here. Then we can start the lesson. So it is a M2 part, and then welcome you all to the M2 lessons. And I'm Mr. Lang again. Okay, so we'll have an introduction of the lesson today, of the whole of the syllabus of M2 today. So first of all, about the textbook, to show again, make sure you have it next time. Next time we will start using it. So you can refer to the webcam at the lower right corner. And then so this is the M2 textbook. It's that M2 here. and then the lower part volume 1. So this year we'll mostly use volume 1. And if you also refer to my teaching schedule, you can also see we will use volume 2 at the end. However, I'm considering whether you will need to buy the volume 2 or not. Maybe we can buy it next year when you are in Form 5. Okay, so this is about the textbook first. But today we will probably not use it because we're going to introduce you something for M2. M2, the full name is Calculus and Algebra. And algebra is a topic that we have heard about it for some time already, and which means using symbol to represent numbers. Therefore, here today we will first introduce some symbols to you. So just as I mentioned yesterday in WhatsApp, that be prepared that you will see more, you will see some many new symbols today here in the lesson. But then don't be afraid. Usually when in the first lesson I introduce this new symbols to M2 students, they usually are afraid, oh, there are so many, I cannot remember them. But don't worry, this is a long period of time. You are going to have like 3 years for you to remember, for you to get used to all those symbols. And then so don't worry, just every time when you are not very sure, you can refer to some reference. You can go back to reference. For example, I will highly suggest you now to have a notebook and write it down. I also prepare my notebook for doing all these lessons, and therefore so it is highly suggested that you have a notebook to write down important things, but not just refer to the textbook, because sometimes the textbook is also very thick, and then it is not easy, not convenient to refer while okay, so if you have a notebook, then you can refer to things easily. Okay, to begin with, whenever we talk about higher mathematics, we always begin with sets, and therefore so I start writing on the notepad here. And so we always begin with sets whenever we talk about mathematical objects. A set in mathematics is simply, the definition is simply a collection of objects. The definition for a set is simply a collection of objects. So well, what about what objects are we collecting then? So what the sets collect, what are the objects that the sets collects? Then it depends differently. Under different contexts it may be different. But for mathematics, most of the time we will be talking about numbers. Therefore, the objects we refer here may probably very much about numbers. On the other hand, well, don't forget that there are also different kinds of numbers. For example, when we are in primary school, or maybe even younger, when we are in kindergarten, we first learn the easy counting numbers like 1, 2, 3, 4. And then when we get a little older, we learn other kinds of numbers. For example, decimal numbers, 4.1, 3.14, etc. While finally, maybe later, we also learn other kinds of number like fractions, 1/2, 4/7, etc. So different kinds of number, and therefore the collection of objects will probably be numbers in mathematics. However, there are other more interesting things. For example, if some of you have already read ahead the compulsory part chapter 3, it is about function. And then so function can also be is also a mathematical object, and therefore we can also collect them as well. And so the idea is that set is just a collection of something. Okay, so it can be any objects that is related to our practical use. And or using an analogy, then a set can be considered as a box to put things in. Then it is a set. For example, so a set can be if like we have some numbers like 1, 2, 3. I use a thinner pen here, and so a set will be objects separated by commas and then with curly brackets, or sometimes we call this the braces, the bracket. And then so this is a set. This is a set with the elements 1, 2, and 3. Okay, so this is a set with 3 elements. Okay, so a set with 3 elements. And sometimes if we like to give name to it, for example, you know, before we like give name to points, point A, point B, point C, or we also like to for a parallelogram, we would like to name it parallelogram A, B, C, D. So if a set like this, we also want to give it a name. Usually we use capital letter. Then for example, we can call it the set A. Okay, then the number of elements of A, it means that how many things are there in the set. Then there are altogether 3 elements. Okay, so you can just consider a set as a box holding something. And let's see another example. So what about this? Maybe I just make up some numbers like -6, 4.5, and then pi. You know, pi is also a number. Okay, pi is also a number, which is 3.1415, etc. And you can press calculator for the 10 significant figures. Of course, you should also know that the 10 significant figures are not everything, because there are more. In fact, pi is a special number that it goes on forever, and not just goes on forever, but also it does not repeat any pattern. Okay, so we will talk about this maybe shortly. And then maybe a few more like 8, and then maybe we give 9/2, and maybe more -16. Okay, then maybe and I call this set the set B. So then could you you can answer in your chat room or whatever, or answer to yourself, have an idea to yourself. So if I'm asking how many elements are there in the set B, okay, so could you say how many elements are there in set B? So you can answer in chat room, or you at least even you are you don't want to type anything, but still you have an idea in your mind how many elements are there in the set B. Okay, 6. Anyone has other ideas? Anyone has other ideas? You will know it later. You will know more about this later. I usually like to set traps in lessons, especially when I ask, "Are you sure?" Then you better also think really, oh, is it really that answer? Maybe think again. Why is it so? Because I would like you to also to see what is the special thing about this, or differences between the set A and the set B. Okay, so I see many 6. That's very good. That's very good, because you seem understand the number here. Well, but then it is a little bit different. Is that because I also take it as another example? Is that there are 2 of the things are really in fact exactly the same. The 4.5 and the 9/2. In fact, they are the same objects. And then so even I put it in the set, but they are in fact the same thing. Therefore, we don't count them as 2 different things. And therefore, when we say for the set B, the number of elements in set B, okay, I change it back to red. Number of elements in B, then it will be in fact only 5, because 4.5 and 9/2 are the same thing. Yeah, and that's what Jack has said in the chat room. That's very good. By the way, it is we may not use this notation very often, but then sometimes to make things easier, more convenient, because you see I write number of elements, there's so many letters, and I myself, in fact, I'm a quite lazy person, and I don't like write many words, and therefore you may also use the notation with two vertical line and put a B inside. Then it means the number of elements in a set. And in the first example, we can also write the number of elements of A is 3. Okay, so just a notation. So two same things are counted as one element only. Yes, that's right. That's right. So it is to answer in the chat room. Okay, two same things are counted as one element only. But then we have to be sure about the meaning of same. Here, of course, 4.5 and 9/2, they are the same thing. Therefore, it doesn't count as two different elements. Okay, but on the other hand, later, near the end of this lesson, I'll give you a short quiz in Google Form, in the format of a Google Form, and then you will see some more examples. Okay, so far, is there any question about the concept of set? It's just to collect some objects in mathematics, a collection of objects in mathematics. Any questions to you? Any questions about sets? Is there any questions? If there are no questions, you can put a 0 in the chat room. You can type a 0 in the chat room, or no, or whatever. So try to let's have more response during the whole lesson. Okay, so don't be afraid to type something. If it's okay, you understand it, so try to type a 0 or no or whatever. Okay, thank you very much. Okay, so I'm getting many responses here. Thank you. That's very good. Okay, so now then next we will move on to see more examples. So you see that there are two examples here as set A and set B, and then I'll turn to our next page and then see more important or we'll use it a lot in our later teachings about some common examples of sets. Okay, so the common examples. So as sets are used to collect something, therefore some common kinds of numbers we will have special symbol for them. For example, the first most easy one will be a set with nothing, and we call this an empty set. Empty set. Empty set simply means a set with nothing inside. When I say nothing, it really means nothing. Okay, therefore, an empty set, to write it explicitly, then it could be a open bracket and then a closed bracket. Then this is an empty set, a set with nothing inside. And sometimes this is also useful to this is also usually used. Therefore, we don't want to write so many brackets. We can also use a symbol called phi. This is a Greek letter phi. The pronunciation is phi, phi. And then we also use the Greek letter phi to represent an empty set. So phi or the full name is called empty set. It means a set with nothing in it. And when talking about empty sets, it is also interesting to say this example as well. So what about this? Do you think it is an empty set? So I try to put it down. Okay, and it's an extra example. So what about this? Is this an empty set? So let me have your idea. Okay, so what do you think? Is this an empty set? The example I've written on the screen, is it an empty set? Do you think yes or no? Yes or no? Do you think it's an empty set? Okay, yes, no, yes, no. Oh, that's good, because there are different kind of opinions. That's good. Yes, no, yes. Is it an empty set? Yes, no. Okay, so let's recall what's the meaning of an empty set. An empty set means it is a set with nothing inside. Okay, it's a set with nothing inside, and then we represent it with the symbol phi. Okay, a set with nothing inside. So what about this? What about this? Is it an empty set? Is it a set with nothing inside? So to understand what does it mean, it means that in fact, if we write it in the full form, that means we don't use special symbol, we just use brackets. Then it is a set. Is it really nothing inside? Is it really nothing inside? In fact, no. It has an empty set inside. And therefore, it is, if we put it into a full form, then it will be a set with an empty set inside. So it is like the one I show on the screen here. The red one is the set we are considering, while the green one is the thing it has inside. It's like
之後可唔可以 send 份筆記
？Sorry，what is it？ 唔好意思，喺邊度？係 chat room 定係喺 Discord 定係邊度嚟嘅？喂？Oh, okay, whatever. It doesn't matter. So if you want to say something to me, feel free to do it in Google Meet, or feel free to do it in Discord. By the way, if you have entered my Discord server, maybe I also introduce it a little later at the end of the lesson. Okay, so now back to here. So the example here given is a set with an empty set inside. Therefore, it is not empty. It's just the object it has inside is the empty set, but the set itself is not empty. And therefore, it's like if we want to put it in an analogy, it will be like we have a box with an empty box inside. And then would you say the outside box is empty? Then we will say no. Okay, so that is the difference. Alright, so you and please note that this is not an empty set. This is not an empty set. So it is a set with empty set inside is not an empty set. Because if it is, then it will be something really confusing. Okay, so the first common set, I will probably say it is the most simplest because it has nothing inside. Therefore, it is we call it an empty set. And by the way, the number of elements in an empty set, since it is empty, the number of elements in an empty set is 0. And it is the only object, the only set that has 0 elements. Other sets will have some elements. For example, even this set has 1 element because the element it has is the empty set. Also, note the difference. Try to note the difference. Oh, YouTube link. Oh, you lost the YouTube link. Oh, okay. Okay, so then this is the empty set, the first one. And we may then next move on to more absolute value. Okay, so yeah, absolute value we will talk about it maybe near the end, but then we will talk about sets first. So we will also see more different kinds of common numbers. For example, just like I mentioned before, in kindergarten we learn some easy counting numbers. And then so next we are moving on are the natural numbers. Natural numbers means the numbers 1, 2, 3, 4, 5, etc. In fact, when you later, maybe if you will further study in university for mathematics, you will see mathematics textbook in university. Okay, and then so a natural number may have a little different meaning. Basically, it will include all the counting numbers 1, 2, 3, 4, 5. Some authors, some writers would like to also include 0. Some writers like to include 0, while some others do not like it. So it depends on different writers. But then, usually in our textbook or in our context, then natural numbers are 1, 2, 3, 4, 5, maybe not include 0. But then don't be surprised when you go to university, you read a book and it says, natural numbers are 0, 1, 2, 3. And it doesn't matter because different authors may have this slight difference. So natural numbers 1, 2, 3, 4, 5. And what about a set that contains them all? Then we write this set, we give it a special name because it is also very common used things. And then so we will write as a natural number set like this, like a capital letter N. It is worth that you try to write this symbol by yourself. It's like doing practice.嗱，大家可以練下呢啲點樣寫啊，練下呢啲點樣寫嘅嚇。Okay, so the natural number set we will represent it as a capital letter N with a little thicker in the middle, a little thicker part in the middle, natural number. Okay, that means all the counting numbers 1, 2, 3, 4, 5, etc. So how many elements are there? How many elements are there? How many, sorry, change back to the pen. How many elements are there for the natural number set? Okay, so try to be serious in the lesson, okay? So how many natural numbers are there? How many elements are there in the natural number set? Or maybe cannot write easily. Okay, yeah, infinite. Okay, so infinity. The number of elements in a natural number set is infinity. And by the way, there are other, maybe when later you learn more in higher mathematics, but may not in M2, really university things. There are many different kinds of infinity. For example, natural numbers is a kind of infinity, while in fact real numbers are another kind of infinity. But we will also talk about real number, but we may not talk about infinity things. Oh yeah, I like the symbol given by Brian. Okay, so that is inverted H. Maybe not inverted, it's a rotated H symbol, the infinity symbol. Okay, so it is natural numbers. And and next one we will talk about is after we have natural numbers, we also it is because of course historical reason that when people trade there will be a gain or a loss. Therefore, to represent loss, then they may also use negative numbers. So together with natural number and the negative numbers, we form the integers. Integers means the whole number, and which means it is a 0, 1, 2, 3, etc. But on the other hand, we also have -1, -2, etc. And then so a set collecting all these is represented by the symbol Z. It's like N, but then it's like N again, thicker in the middle, and the symbol is Z. While if you check Wikipedia, you can check why we use Z. We don't use I, integer I, right? But why you use Z? Because I think it comes from German. In German, Z means the numbers, and so an integer set will be Z. Next, we are then moving on to something more interesting. So far so good? Everyone, so far so good? Is it okay right now? Up to here? Up to here, is it okay? Yes, thank you. Yes, okay, good. Thank you. So natural numbers, integers. There are 3 more we are going to talk about. 3 more, altogether 5. And then so next, the rational number. This kind of number, in fact, I think you learned this before in lower form, Form 1, Form 2, or Form 3. But then it is not used, the name is not used so often. Therefore, maybe you have forgotten it. It's okay. It's okay, I understand. Because it does not use often, so it will not remember very well. Rational number, the Chinese translation, the Chinese name is also called 有理數, 有理, rational. It means like when you say someone is rational, you say he or she can think very well. Then we call him or her 有理, rational number. However, I think this is a very bad translation, because in fact, this rational number comes from the word ratio instead of rational. This rational number word comes from ratio indeed, and to be precise, a rational number means a number which is in the form of ratio of 2 integers. That is, to be more precise, we call them fractions. So for example, 1/4, if we can represent it into 2 integer ratio 1 to 4, then it is a rational number, 1/4. More example like -2/3, then we can represent it as the ratio of 2 numbers, -2 and 3. it can be considered as -2 to 3. Therefore, it is also a ratio of two integers. And then for symbol, collecting all of these numbers, then the set is called Q. The set is called Q. The capital letter Q. If you want to know why Q, then I think probably it's about quotient. Quotient means divide, and then ratio is also related to divide, and then therefore we call the rational number set Q. All these symbols are universal, which means later when you study mathematics in a higher institute like university, you will still see these symbols. They are used universally. Everyone use it and understand what it means. Okay, then this is the rational numbers, and there can be more. So okay, I think it's better for you to decide. What about this? 6. Is 6 a rational number? Is 6 a rational number? Yes. But when you say yes, you must explain. You must understand and explain to yourself why we can say it is a rational number. Yeah, that's very good in the chat room. Okay, yes, 6 means 6 over 1. That means it's also still a ratio of two integers. Okay, so ratio of two integers. Therefore, 6 is okay. Yeah, because you can consider 6 as 6 over 1. Okay, very good, very good. So if you can point this out, and it means you can understand very well. Okay. Square root 2. What about square root 2? What about square root 2? Okay, yeah, very good. You can say the other word, irrational number. No, okay, no. But what about, okay, is it square root 2 over 1? We can write it as square root 2 over 1. Then it is also a ratio of two numbers. Then why don't we call it rational numbers? Cannot be represented by fractions. Irrational. Okay, no, okay. But well, what about square root 2? We can rewrite it as square root 2 over 1. Then why can't we say it is rational number? No, okay, yes. The answer is no. Okay, so very good. Why is it so? Why we have this, but still we don't consider it rational number? Because we call rational number means ratio of two integers. It has to be integer. But square root 2, of course, it is not integer. So square root 2 over 1. Also, this upper part, the numerator, is not integer. Therefore, it is not, in this case, it is not. But then, oh, okay, so you may also argue, oh, okay, what about it is not square root 2 over 1? Can we find two numbers in their fraction and make them into a fraction and it becomes square root 2? This question is a little bit harder to explain. That means can we find other numbers? Okay, can we find other numbers that you over them and then you still get square root 2? This is a harder question to answer. If you want to know, I can show you this. In fact, I have shown you this before. See if you remember. I have shown you this before. It is in the notes on math lesson. This did you ever read this whole thing? It may be not easy to read, but then okay, I hope we can take a little time. I know time is not very enough, only 15 minutes left. And then so this question 3 just an example to prove that root 2 is an irrational number, which is not a ratio of two integers. Okay, so here we have a special skill of proof called contradiction. Maybe we will have later some part of the lesson, maybe later lesson, not today, to explain what is the meaning of contradiction. We suppose the opposite, the result is wrong. That means root 2 we can make it into a rational number, and then that is we can write it into a fraction form. And by the way, you can also see here we try to use some symbolic representation to save space. We always use these symbols to save space. That is PQ. This symbol is the belong. I will also talk about it later. So belong to the set is the integer set. That means we can find integers. So that square root 2 is represented by here. And then we do some rearrangement. We do some manipulation. And then we have a result. And then I try not to explain too much here because I don't have enough time. And then, then if we do more manipulation and find that finally we have P is an even number and Q is an even number. That means if we can write square root 2 as a fraction of two integers, then both P and Q must be even. However, it is impossible because if you can write in a fraction, then the fraction can always be simplified. If you have an upper even number, lower even number, then you can always simplify. Why is it a must? Therefore, both PQ must be even number. In fact, contradicts to our common sense, and therefore, we prove this as root 2 is irrational. The idea of proof by contradiction is not easy, and maybe I will later spend like a lesson or half a lesson to introduce this to you, or maybe probably after we return to school, because I think it is easier to do this in when we return to school, and it is not very convenient. I do it through a web camera. That's not very good, and I hope we can do it really soon because the result of some days ago, we know we can return to school at September 29. We can return to school at 29 at the end of September. I hope it is okay. Okay, then root 2 is irrational. And I also like here to mention more common irrational numbers to you. Therefore, if you have put some notes here, note that, put a big cross. Root 2 is not a rational number. And in fact, any square root that is not beautiful, like for example, square root 3, square root 5, square root 6, square root 7, square root 8, etc., they are all irrational. But we do not have a symbol for irrational number. Because rational numbers seems more useful than irrational numbers, so we don't have a special symbol for it. Okay, so root 3, root 5, all the square roots. And one also important example to you will be the special number when we use to calculate area or circumference for circle. That is the special constant pi. It is also irrational. Pi is irrational. While talking about, oh, can you prove it? Can you explain why pi is irrational? It is much more difficult. Much more difficult than the square root 2. Therefore, I try not to do it here. Okay, so so far we have this new one, rational number. Is it okay for you all? The rational number set. Is it okay for you all? Is it okay? Feel free to ask if there are any questions. Feel free to ask. Ask at any time. Feel free to ask if there are any questions. So finally, in fact that would be the final thing about set. But there are maybe a few more other things to introduce. Finally, the real numbers. Real numbers just means all combining everything, every kind of number we have already learned, like integers, rational numbers, or even irrational numbers. Then combining everything together and collect them as one. Then this set is the real number set. And then since it's a real number, so we call it the symbol we use is the R. Okay, R. And then this real number simply means rational and irrational. And then a little later in our compulsory part, we will also learn a new kind of number, which is after real number. We also later, but I just say the name here. I don't want to talk more about it because later we will talk about it in the compulsory part. And then later we will learn a new kind of number is the complex numbers. And a complex number is something related to square root of -1. And for the set symbol, we use a C for complex number. And to represent sets, all those set symbol, we have some thicker lines in different position. For example, go back here, the natural number, we have a thick line in the middle for n. Integers, we have a thick line in the middle for z. And the rational number, we have a thick line on the left hand side. While the real number, we have thick line on the right hand side, on the left hand side. And complex number also. Okay, so these are the common used sets. So to show why we have sets, because we want to simplify representation. We don't want to, every time we say, for example, we say 4 is integer, then you need to write many words. 4 is an integer. So why we use sets? Why sets? To simplify, because we can use symbol to show our statements. For example, we want to say 4 is an integer. Then there are so many words we want to write, and you know I am lazy. I don't want to write an integer with no s. Wrong grammar. Okay, sorry, wrong grammar. It's an integer. Then I don't want to write so many letters. I can just use the symbol 4 belongs to the integer set. Okay, 4 belongs to the integer set. And then so to make it clearer, this symbol is called belong. And then it means 4 is an element of the set Z. And then so we use the symbol belong. While on the other hand, we just mentioned earlier that square root number, square root of not beautiful number, it is not rational number. Therefore, we can also write like square root of 10. Of course, it is not beautiful, and or you can also press the calculator and check. Then it is not a rational number. Okay, so that's the parts for sets. That's all the parts for sets. Any question up to now? So we have learned different notation for sets, and also during the process, we try to explain what are the meaning of different kinds of numbers. Like rational number, we review it, and while real numbers, a combination of everything, we also talk about that. And then so and they are set representation. And why we use sets? We want to simplify our notation. So if you want to say this sentence in full, it will be like square root 10 is not a rational number. And then it is really long things, and we can use a short symbol to show this idea. And that's also, we can say, our first part of our M2 things, to get used to symbols. Okay, is it okay? So, okay. Then now, finally, some more useful things we will use. Also, notation first. Sometimes, to show a range of numbers will be useful. For example, like in Form 3, we have learned the inequality result. For example, it's like x between 1 and 3. Then we can represent it here. It's also a notation you can find in your textbook, but then I don't refer to it here. So for example, if we are to refer x is between 1 and 3, then by the way, note also that when we say between 1 and 3, this is there is a line under the inequality signs, which means we also include x. We also mean x is 1, x is 3 are okay. Now we include 1 and 3, include the both ends. And then if we want to show this in a symbolic way, in fact it is already symbolic, but then an even shorter way will be we use a square bracket 1, 3 to show this. While before I go on, before anything else, give more example. What about if some of them we don't include the endpoints? That means, for example, what about 1 is not included? Then another color, so 1 is not included. Then in this case, the side that we do not include, we will use a curly circle bracket instead, a curved bracket. That is 1, 3 to represent this. Or even more interesting would be, what about is only a one-sided inequality? Then like x bigger than or equal to 6. Then we will represent it as it is between 6 and infinity. But we include 6, therefore a square bracket here and a curly bracket on the right hand side. Also, there are some notations. And these kind of range, we call them the intervals. Intervals 即係一個區間啦，即係一個範圍咁解。It's like a range. And when we write these symbols, we also mean they are the sets. That means we can say, for example, okay, I put it in a corner here. For example, we can say 2 belong to the set 1, 3. Because 2 is inside the interval. And we can also say pi is not in the interval 1, 3 square. Because pi is 3.14 something, and then it is not in the range, then we can say it does not belong to the interval. And finally, 2 pi, then it will be double of pi, then it will belong to the 6 and infinity set. Okay, so we also, this is kind of a symbol for sets. Then time is nearly up. Just one final remark, final thing about something you also mentioned in the chat room before is about absolute value. This is also something we will use later when in different topics. Absolute value simply means sometimes we don't want a number to be negative, and then so we use absolute value to make it non-negative. For example, the symbol is putting 2 strokes around a number. That is like absolute value of 3. Then it is 3. Absolute values just mean to make non-negative. And the absolute value of 3 will be 3. And more example will be absolute value of negative 4. Just make it not negative, then it will be 4. While further example would be like, what about 5 minus 6? Then 5 minus 6 is negative 1, therefore absolute of negative 1 will be 1. It's just like this, the absolute value. So sometimes when we want to represent the number, we want to make it not negative, then we use absolute value. We put 2 vertical lines, 2 strokes around the number, and to make it not negative. While a boundary example would be, what about absolute value of 0? Then it is 0, because 0 is not negative. 0 itself is already not negative. Okay, so these are some notation here for today. And while next time, then we will kind of start chapter 1, but then again still some notations to begin with. And we will talk about the first part of the chapter 1, which is called the summation symbol. It's also why we use symbol. We want to use symbol because we want to make things easier, shorter. We don't need to write a lot. Therefore, all those symbols are for us to write easily. But then, in the case when you really don't understand those symbols, make sure you change it back to the long form. Then you can understand easier. So the symbol is just for easy writing, for short. But if you don't understand sometimes, write the full form and then you will understand more. Finally, I suppose all of you here are in the YouTube part because the Google Meet is, most of you have already left. It's okay. Finally, I will put a short quiz here. So I know time is already up, but then it's a short quiz, and so try to finish the quiz before the next lesson. Okay, I'll send you a link to the quiz here. and then so you finish this quiz. Of course, you can finish it now because I think it's like 5 minutes thing. You can finish it in 5 minutes. But then, well, if you are so busy, you need to have your lunch right now. Then okay. But remember to finish this quiz before the next lesson. And then this quiz is a self-grading quiz. After you finish it, you will immediately know your result, and also you will know the correct answer. Therefore, take it as a quiz and a summary to this lesson. So I will put the link to the quiz here in the chat room. You can also now click on the link and go and do the quiz. Or if okay, you want to do it the quiz later, it doesn't matter. Okay, so you can also do it later, but before the next M2 lesson. Okay, so make sure before the next M2 lesson you finish this quiz, and then that will be all for our lesson today. So if there are any questions, feel free to stay here and ask in the chat room, or you can also join my Discord channel, which we have the link on top. You join the Discord, you can have a very convenient way to contact me, because in the Discord channel there are many different different channels that you can ask the question, or even you can go to voice channel and ask me directly. It's like talking on the phone, so you can talk real time with me. Okay, so that's it. So that's all for our lesson today, and then so see you next time. Okay, goodbye. Any question to ask? You can ask. You can remain here and ask. If not, then I will close this live streaming, and then my mathematics lesson and also M2 lesson will also be like this. Okay, so maybe I close the live streaming right now here then. So see you all next time. Goodbye.